Okay guys, today we're starting two-dimensional motion. Specifically, we're looking at horizontally launched projectiles. So I want to start this video by doing a warm-up. Think about the following scenario. A plane is flying horizontally at a constant speed, and at some point it's going to open up and drop a crate. Where will that crate land relative to the plane if the plane continues to travel at a constant velocity? So I'll go ahead and pause the video and see if you can come up with a prediction. Okay, so we'll take a look at what happens when the crate is dropped. The plane continues to move horizontally at a constant speed, and what we have is it drops nearly directly below the plane. So why is that happening? Well, if the cargo is part of the plane, or the crate is a passenger of the plane, then it's moving at the same speed as the plane. And so that means initially it's traveling at a constant speed in the horizontal direction. When it's released, when it's dropped, we know that gravity takes over, and we know that it begins a free fall, and there's an acceleration, but that acceleration is only vertical. It's pointing straight down. So the vertical motion of the crate is affected, and it's accelerating downward. However, because gravity only points straight down, the horizontal motion remains. So it also continues to travel at a constant speed horizontally. So we can look at kind of like a motion diagram where we look at the horizontal spacing of both the red and the blue dots, and they're equal because it's moving horizontally at a constant speed, but we see the vertical distance increasing because that object is accelerating downward. We'll try one more. Similar to the airplane scenario, imagine that you are in the back of a truck. I'm going to do my best to draw. They're not very good at drawing. And you have a cannon that is mounted in the back of the truck that only shoots vertical. So it only shoots straight up. So I want you to imagine that this truck is traveling horizontally at a constant speed. And at some point during that motion, we're going to fire the cannon straight up. Where relative to the truck is that cannonball going to land? Okay, very similar to the airplane scenario, since the vertical motion is independent of the horizontal motion. So the cannon is firing the cannonball vertically, gravity is affecting the cannonball vertically, the horizontal motion remains the same. So in the horizontal direction, the cannonball travels with a constant velocity, but vertically, it's in free fall. So the cannonball lands directly back into the truck. So the horizontal motion of the cannonball is independent of the vertical motion. Okay, great. I want you to try these two practice problems if you would. Again, pause the video. Try these two practice problems. One is with a constant speed, and another one is a free fall problem. Okay, so when you're doing the constant speed problem, we know that the information that we have is that both the V initial and V final are 20 meters per second. Because that is true, we could say the acceleration is 0, and also that the time is 3 seconds. When the acceleration is 0, if we look at the second kinematic equation, V initial t plus 1/2 at squared, this really simplifies because we have a 0 acceleration to just displacement equals V initial times t. And I could find the distance traveled by doing the initial velocity times time. So we just have here 20 meters per second times 3 seconds, or 60 meters. Okay, so hopefully you felt confident doing that problem. Let's try a free fall problem. How long would it take an object to reach the ground if dropped from a height of 45? So I'm going to go ahead and I will assume that dropped means the initial velocity is 0, so that's some implied data. I also know that it's dropped from a building that is 45 meters tall, so the displacement as it falls is going to be negative 45. Now, I typically use x for all position values, whether they're vertical or horizontal. You may see other resources that would call that delta y. That's fine. But I stick with delta x because on your equation sheet, it's written as, position is x, regardless of vertical or horizontal position. Okay? And I know in order for the kinematic equations to work, I need to know at least one more variable. Since this is a free fall problem, and I'm assuming it's on Earth, the acceleration would be negative 10 meter per second squared. And I want to find how long, or the time at which it would reach the ground. So I'm looking for a kinematic equation that has v initial, displacement, acceleration, and time. So I'll go to the second kinematic equation, v initial t plus 1/2 at squared, and I see these three variables plus time, which I'm looking for. Now, typically, I don't like to solve this equation for time because we have t to the first and t squared. So we would need to use quadratic formula. Fortunately, since the initial velocity is 0, that first term is 0. So this is a lot more simple to solve. I can just multiply by 2 to get rid of the 1/2 and divide by acceleration. And that would leave me with just t squared. To get rid of the squared, I'll take the square root of both sides. So my time is the square root of 2 times displacement divided by acceleration. And our displacement is negative 45. And our acceleration is that of gravity, negative 10. So the time that we have, 2 times negative 45 is negative 9. Or 90, sorry, negative 90 divided by negative 10 is 9, and the square root would just be 3 seconds. So it would take 3 seconds to land if dropped from a 45-meter tall building. Now, those are problems that you've done before, a constant speed and a free fall problem. Let's take a look at something more challenging. When we do two-dimensional motion, when we do something like a projectile, if you imagine the trajectory of something that's been thrown into the air, it's traveling in 2 dimensions. And that's a problem because our kinematic equations only work in straight lines. They are one-dimensional. So what we're going to do with two-dimensional motion is to break it into 2 separate independent motions. So for something that is something like a ball that is traveling in this parabolic path, I'm going to break that motion into the horizontal part and the vertical part. And the reason that I'm doing it is because I know that this object is being affected by gravity only. So once you throw that ball into the air, assuming air resistance is negligible, the only thing affecting it is gravity. And gravity only points vertically, which means gravity is going to be affecting the vertical motion, but will have no effect on the horizontal motion. And that allows me to start each problem with a known acceleration. In the horizontal direction, there's no acceleration, and in the vertical direction, the acceleration is negative 10. So I have an advantage here where I'll always know the acceleration in both dimensions. Okay? So keep that in mind. When we have a two-dimensional problem, we're going to have to break it into separate, independent dimensions. So I have the horizontal and vertical. Let me try that with a horizontally launched projectile. So at the top of a 45-meter tall building, I launch an object with a horizontal speed of 20 meters per second. Now I know that the trajectory of this ball is going to be something like that. It's going to be half of a parabola, and I want to determine how far away it lands. So just like any kinematics problem, I'll list my acceleration, displacement, v initial, v final, and time, my 5 kinematic variables. But this time, I'm separating it into the horizontal, or the x motion, and the vertical, or the y motion. So in the horizontal, I know there is no acceleration because gravity only affects the vertical. So my vertical acceleration is negative 10. In the horizontal direction, I want to find the distance. I don't know it yet, so I'm going to leave that as a question mark. And in the vertical direction, it looks like from where I start to where I end up is 45 meters down. So I'll go ahead and put negative 45 meters for my vertical displacement. The initial velocity, when I'm looking at this vector, this is an object that's horizontally launched. So this vector is completely horizontal. So that 20 meters per second is a horizontal component. And vertically, well, how much upward or downward is that arrow pointing? It's not. So I would say the initial vertical velocity is 0. Okay? And on my vertical side, I've got three things. And anytime I have three things, I know I can find the other two using the kinematic equations. Now I'm looking at this and it seems pretty familiar. We have an acceleration of -10, a displacement of -45, and an initial velocity of 0. That is exactly the free fall problem that we had done before. And we had found that it would take 3 seconds. So with that same information, I can use 3 seconds. I can use the result that we had found before. It's going to take 3 seconds to land as found from the vertical. Now, typically, because horizontal and vertical motion is independent of each other, we could never take a value from the horizontal side and use it on the vertical side. And that's because every one of these variables, acceleration, displacement, and velocity, are all vectors, which means the direction matters. However, time is a scalar value, which means 3 seconds in the vertical and 3 seconds in the horizontal mean exactly the same thing. It's a scalar value, and direction is not necessary. So I can use that 3 seconds that it's going to take to cover a vertical distance of 45 meters, and I can use it on the horizontal side. So now I have the time that it's going to take this object to land. And if I want to determine the distance, I can use my initial velocity of 20 meters per second and my time of 3 seconds. But wait, that's exactly the constant speed problem that we had done before. So 20 meters per second for 3 seconds, this object is going to travel 60 meters. Okay? So two-dimensional motion sounds very complex. It seems like it might be a challenge. However, if we break it into two separate problems that we've already done before and that we're comfortable with, you have a constant speed problem in the horizontal direction and a free fall problem in the vertical direction. It seems a little bit more manageable. Okay, so hopefully that'll get you started on horizontally launched projectiles. Thanks for watching.